Chapter 2. Okay, manufacturer of boots plans to conduct an experiment to compare new method of waterproofing to the current method. The appearance of the boot is not changed by either method, and the company recruits 100 volunteers in Seattle, where it rains frequently, to wear boots as they normally would for 6 months. At the end of 6 months, the boots will be returned to the company and evaluated for water damage. Okay. This is very typical. Describe the design for this experiment that uses 100 volunteers. Include a few sentences on how it would be implemented. Okay? This is a very typical question for the AP exam. How would you design this? Go. Adam.
You could use the simple random sample to use 2 groups of 50. One that would be wearing the boots for 6 months, and one like
So we're saying use an SRS to
make 2 groups of 50 people.
subjects. Okay.
Group 1 would be wearing the boots normally for 6 months.
Which boots?
Current method.
Adam? Which boots?
The ones in my which one is it? The waterproofing boots?
The new one? Okay. Now what?
And compare the water damage to each.
When?
At the
When?
After 6 months.
The water damage in each group will be compared. Good. Any others?
I have a question. Like whenever I did it, I did a method by blocking. Am I allowed to, or is it supposed to be hinted in the question that it should? There's a
Yeah. If you're gonna block, what are you blocking by?
woman by gender.
By gender. Why would you block by gender?
Because I don't know. I feel like once the females would take better care of their shoes and stuff.
Okay. So, it is that women will take better care of the boots than men. So it's really important that if you're going to actually describe a blocking design, you just kind of say what you're blocking by and why you're blocking by that variable. Therefore, a blocking design will be implemented. Woo. Will be implemented by gender. Let's finish this one first, okay? After separating subjects by gender, what's going to happen?
You split in group genders from few women, so you split that into 25, 25, and 125 gets the new method and the second.
You have that basically, but
I mean, no, you don't split them. Sorry, just the 15 and
we don't actually know how many men and how many women we have. Okay.
Are you allowed to
Need to assume or no?
say that there's exactly 50 men, 50 women?
Not unless they tell you. Okay. So each block will be use an SRS to create two equal sized groups. One of the groups in each block will use the new method, and one of the groups will use the old method, or the current method. Okay, so that's a blocking mechanism. Yeah.
To do that one, since we don't know the number of many, we have to be sure that each block will be the number.
Yeah. So you create two, right here, two equal sized groups.
So there's no way we can guarantee this, but this is what we would do.
Yeah. You can't give an exact number unless you know exactly how many men and how many women you have. Right. We'll get into that in a minute. There's actually waiting to see if anyone has the other method. Did anybody have the other method? We've done two.
I mean, you could do a match pairs.
Okay.
Okay. So you can get, you could put the 100 people into the pairs of similar types of people that have like a similar workday.
Similar what?
Workday or similar lives or similar people.
We have to be really,
Specific.
yeah. Why are we pairing them? Adam?
Could we care about like physique, similar size, similar physical activity level?
You could pair the subjects.
There's ants everywhere.
Yeah, you should have seen it before I got here.
Yeah.
Just
I still have tape on my arm. Pair the subjects. What are we saying? Is that agreeable? Similar
Yeah.
physique. Okay. What are we gonna do with the pairs? Hmm?
Flip a coin to decide whether we're going to
Flip a coin for each pair. To separate the pair into two groups.
If we say random allocation for each pair is supposed to be.
I would, yeah, you could say random allocation, but I would make a point to actually say SRS instead. Okay. Yeah.
So it's not important to differentiate which SRS you're using?
No,
Like,
not
should
really.
you explain that you'll use random generator or something, or should you just write?
You can just say an SRS. Or in this case, flip a coin. Anyone do an own control? Guess which design was preferred by the AP reader?
Oh,
Own control. How would we do an match pair own control? Yeah.
Right, so you do SRS.
Okay. So we could use an SRS to separate the subjects into two groups of 50. Okay.
Group one where the new boots for the first 3 months.
Okay.
And then group 2 were the current groups for the first 3 months, and the new groups for the second 3 months.
Okay.
And then after 6 months, compare their opinion of the groups and compare the water temperature.
Sure, I'll do it. Hmm?
What's that one called again?
That's a match pair design. Match pair own control. Hmm? Sharon?
For the AHU test, would they maybe do something similar where they would ask you to do, like, explain it, but explain it in a chart?
No.
It would never.
No. The chart we kind of use so we can understand the
Yeah.
design, but substituting a chart for words is not good. Yeah. I can't quite hear you.
If they're doing each type of group, can you make it 6 months and 6 months, or is the limit 6 months and you need to separate?
I think it says specifically here that that they have 6 months to do the experiment. Yeah.
Is the benefit of own control is it's more accurate, it's not going forward, you have each person doing both methods rather than just one person doing it, right, with different people.
I think you have the idea. I don't know if I'd use the word more accurate, but the big thing here is that a source of variability, and the big source of variability is each person has different, walking patterns, or they use their boots differently. So the greatest source of variability here is actually the individual wearing the boot.
Okay, and then you get each one wearing both.
And that's kind of the idea, is if the greatest source of variability is the individual experimental unit, then you want to try to use a match pair as much as you can. Okay. There's another one. And it's kind of, here's another match pair. Separate into 2 groups. Group 1 will wear the new boot on their left foot. And the current boots on their right foot for the second 3 months. After 3 months, group 1 will switch boots. And wear the new boot on their left foot. No, on their right foot. And the current boot on their left foot. Mm-hmm.
When you have to wait the second 3 months.
What's that?
Group 1 will wear the new boots on their left foot for 3 months, and the current boots on their right foot for the 3 months.
Good. Thanks.
And that's also match pair on control.
That's another match pair own control. This was actually the one that they hoped that you used. Yeah.
On the AP test, will they take off points if you didn't use the match pair own control that they prefer, or as long as you have one experiment that you use?
If you have an experimental design that is well written and makes sense for the experiment.
Okay.
Right. But I think I remember there was a problem where if you didn't use a block design, they took off points. So they,
If they indicate
yeah.
like in the 100% game, like every block thing that you have to do based on which
Well, the problem is they weren't very specific about what they wanted. For somehow, you're magically supposed to surmise that they wanted a block design. So, yeah, kind of a problematic in that they don't always tell you exactly what they want. They want you to be a bit of a mind reader sometimes. So that's a problem with the AP test. Any other questions with 2002 for response 2? I think we've kind of talked it out. So if there's anything else you have, yeah.
Are we gonna do part B?
Oh, yeah, part B. Part B. Sorry about that. Is it possible that the design could be double blind?
yeah, it's possible the subject does have to know which, whether they're wearing the new method or the current method, and then the experimenter doesn't have to know which one is what whenever he's checking the water.
Okay. The answer is yes. But we got to be careful about how we write this. What are we going to say?
The subject should not know which.
How would they not know, though?
If there's no physical distinction between the boots, the new and the current, or the new method, they would not know which one, like, the left one is current or old, or vice versa.
But as an experimenter, what would you have to do, Morgan?
You would give them the pair of boots at the same time, a right foot and a left foot, and you wouldn't say that the right is currently the new waterproofing and the left is the old waterproofing. You would just hand it to them like it was a regular pair of boots, and then after when you receive that pair of boots back, then you give them the next pair of boots, which would have the left waterproofing in it.
Okay.
rather than the right.
So if we can get back to the so the experimenter would not
Tell the subject which boots which.
identify which pair of boots have the new treatment.
Wouldn't it be fair? Would we be going with the one where the left was new and right was current, or the other?
Either way,
Okay.
doesn't matter. To the subjects.
That's fair. Shouldn't the experimenter not know either which one is which?
So what do we need to do for the double blind? Also,
The experimenter does not know which subject has which boot.
how's that going to work?
Number them and keep the number
That's good. The boots should be numbered. Okay.
Odd numbers or
As their only identification. The treatment used on the pair of boots should only be known to the researcher. Yeah.
Why is that double blinded if the researcher
Double blind means that the subject doesn't know which treatment they're getting, and then the person collecting the data does not know which treatment the subject received.
So the researcher only knows which numbers have the boot, but they don't know who has the boot.
Yeah. Hmm?
Is the reason for this not, so there's no bias for construction of roofs and damage on them?
Yeah, it has to do with bias. It has to do with a lot of, the researcher wants the new boots to perform better. So they may not look at the boots with the same pair of eyes if they know that it's new treatment. Dan?
What if something's coming out that it's not, like which one is which during the experiment?
That's kind of out of our scope. We can't really do anything about that. Every effort should be made to make sure that the boots are identical. But beyond that, the real world.
No, but like, for example, like, they can assess the water damage for themselves, like during the experiment.
Yeah, but they wouldn't know which water damage boot was the new one, which one was the old one. They would just know that one of them seems to be getting more water damage than the other. Adam?
So what's the difference between the researcher and the experimenter?
The researcher is the one who's going to be crunching the numbers. The experimenter is the one who's implementing the, the design.
So the experimenter has to be blind, not the researcher.
Yeah. Are we talked out on 2002? Good. Cool. How are we doing? Look at that perfect streaming. Sick. Yeah. I think we're gonna save 2005 for maybe some other time. So let's go back to the multiple choice problems. Let's kind of talk through those. So number 1. You're doing a research project on the attitudes toward fast food and decide to use as your sample the first 25 people who entered the door at Fatburger. What do we think of that sample? Systematic?
No.
Convenience?
Yes.
Yes. This is a convenience sample.
What's a self-selected sample?
When they select themselves to be part of the treatment group.
I was like themselves to be a part of it.
Yeah.
Is that
Or a
what I-
voluntary sample. Alright, so yeah, that is a convenient sample. There was no effort made. No effort was made to use randomization. Okay. 2. How does an experiment differ from an observational study? Experiment uses a sample. Yes. So does a observational study. Observational study lacks a control group. Well, you can kind of create a control group based on the characteristics of the people in the study. Okay. Remember, in an observational study, you're saying this person fits what I would describe as a control. They're not using Crest toothpaste, so they're part of my control. And everybody in my survey who used Crest toothpaste, they're going to be my treatment group or my experimental group. So it is kind of possible to have a control group using observational studies. In an experiment, the researcher imposes a treatment, and the big word there is imposes. So you have to tell the subjects what to do. Yeah, that's true. So, an experiment. Dead ant die. Imposes. There we go. Hmm? Yeah.
Let's say there's a study that you're like showing like a video on a TV and you're observing the people's reactions.
Okay.
Would that be an experiment because you're showing a video, or would that just be an observational study?
I would say that's an experiment.
So it would be an observational study, just watching them watch whatever they want.
Yeah. Yeah, if you're making a decision for the subjects, like you will watch this video, then that's going to be an experiment. Yeah, Brett.
Just so then if you just walk into any movie that you didn't pick out and you did it, that'd be an observational study.
Yeah. Where are we? 3?
Yeah.
Oh, great. I know we all love these 1, 2, 3 questions. I know I do. Sarcasm. I don't really like these. Data was collected in 20 cities on the percentage of women in the workforce. The data collected in 1990 was collected in 1990 and again in 1994. Gains and losses were the measurements upon which the study's conclusion were to be based. What kind of study is this? Match pair design, observational study, experiment using block design. I think the easiest distinction here would be, is this an observational study or an experiment? Okay. So it should be pretty clear that this is an observational study. We're not imposing a treatment on the cities. So this is an observational study that kills letters 1, 3, and A, C, D, and
No, E is still available.
E is good. So it's either B or E? B or E. Okay, so and that really hinges on is this a match pair design? Is it a match pair design? No, we're not matching pairs.
Well, the 1990 data and 1994.
So it could be
Yeah, it is. We're matching data. One group is the city in 1990, and the other one is percentage of the city in 1994. So we're matching, say, Los Angeles from 1990 with Los Angeles from 1994. Okay, this is a match pair. Match pair, i.e., we are matching Los Angeles in 1990 with Los Angeles in 1994. Match pair observational study. Okay. That makes sense why that's an observational study then? Match pair? Everything good? Okay, and number 4. You want to do a survey of members in the senior class of your school, and you want to select a simple random sample. You include 40 students in your sample. Which of the following approaches will generate an SRS? A. Write down the name of each student in a slip of paper and put the papers in a container. Then randomly select 40 slips of paper from the container. Is that an SRS? Yes. Assuming that the students were not, quote, tracked, select 2 classes at random and include those students in your sample. No. No. A is an SRS, right? And what is B?
Cluster.
That's a cluster, exactly. That's a cluster sample. C. From a list of students of seniors, you select one of the first 10 names at random. Then you select every nth name on the list until you have 40 people selected.
Systematic.
That's a systematic sample, yeah. D. You select 40, the first 40 seniors you pass through the cafeteria door at lunch. Convenience, good. E. Randomly select 10 students from each of the 4 senior calculus classes. We're not selecting from every strata, right?
But what if the first senior calculus classes of equal like to each other and then you're randomly selecting from each other? Are taking similar groups? Or senior classes?
Why is it strata?
Well, it seems to me that the group of senior classes is one strata, isn't it? And you're kind of taking 10 from each strata. This is just really. Well, but the thing is, you're not sampling from all of the strata. If this was actually stratified, you'd want to sample from this calculus class. You want to sample from math analysis. You want to sample from, I guess, advanced applied math.
But still not the all stratas because there's not necessarily every case of math class.
Yeah. And then the students who don't take a math class. So this is neither nor here.
How'd you make a cluster out of that?
Cluster.
A cluster method. I don't know.
B was cluster.
No, I know, but I just wanted to try to figure out the difference between cluster and stratified. So if there's 4, like, how would you make a cluster?
So to make that a cluster, you would just pick a number from 1 to 4, and then the entire calculus class is your sample.
So it's not cluster, it's not.
This is not cluster, not stratified, not SRS, right? It's a mess. Okay.
So it's not under.
Yeah, this is really bad design.
Okay.
Kind of guaranteed to have a lot of bias in that. I think the last one we're going to do this period, or at least on tape. Which of the following is important? Control all the variables. I think that was one of our 4 principles of design, right? Randomization, yeah, that was a principle of design. A large number of subjects who control small sample variability. That's replication, right? So all of the above. D. So what did we say? 1 is control. 2 was randomization. 3 was replication. What's the experimental design thing that we're missing here? Control, randomization, replication. We're missing one of the steps of experimental design. No. What are we missing? No. Experimental go back to experimental design. What?
From my notes, it's randomization, blocking, direct control.
No, those are the types of experiments. We're looking for the principles of experimental design, yeah.
Sorry. There's randomization, blocking, direct control. That's what it said under.
Blocking?
Yeah, that's what
You see, I'm kind of like, I don't remember what it was either. That's not good.
you. there's 3 and there's no option.
Oh. I'm seeing blocking also. Yeah, all of the above, right? All are true. Yeah. That's the thing which I don't know why we're putting it there, because no, you don't have to block every experiment. So I feel like there's something amiss here. Maybe I'll look for it. Experimental design. Experimental design. Control, replication, randomization. Oh, no, it's just those 3. I can see why you're looking at me like I'm crazy. Just those 3. All are true. Last questions before I wrap up the recording. Yeah.
In number 1, the choices are random sample and simple random sample. Is there a difference between us that we should know?
That's a really good question. I would always go with simple random sample, because a random sample does not necessarily mean simple random. Okay, anything else? Cool. And then we'll take anything